Hello guys, today we look into another episode of Tech IoT and whatnot, and it's actually the continuation of using the nidaqmx in Python. In the previous example, we have actually seen how to use a simple analog input, a voltage analog input acquisition using Python code, example code, and this is more like a continuation of how to use the voltage analog input finite acquisition in Python code. So before going into Python code, we will look into the LabVIEW example code here. I've just created an example code here that actually uses the basic DAQmx acquisition. We have the step one, which is the configure the analog input channel. Here we actually set the what type of voltage, what are the values that we are actually measuring, what are the terminal configuration. We can actually set it as default, RSC, differential, so depending on what kind of configuration setting that you want to set. After you have set the first step, then next you actually go into the configuring the sample clock. Here, because the acquisition is finite, we will set it as finite sample, and if you want to use continuous sample, you have to probably use a while loop, but that will be in the next episode. Here the clock is actually set as conboard clock, and the rising, we set it as rising edge. And once the third step is actually the starting the task, followed by reading the value. So you can see I have actually set it as 2D array value, multiple channel with multiple sample in the form of DBL data type, and the output can be seen on a waveform graph here. The last two would be to stop the task and clears the task. In case if I missed out, the step one is actually configuring the task, and then we use that task to start our acquisition. So if we press run, as you can see, it will actually generate a sine wave here using a simulated device that you have set it in nidaqmx. So it will actually generate a sine wave with a number of sample of 1000 samples. So this is just an example as for illustration. Now we will actually move into the Python code. For this time, I have actually used the Visual Studio Code as a programming environment, and the reason is actually quite simple, because it's much more easier to actually code. Is actually much more easier to actually code, and you can actually have an overload of the properties and methods once you import the package, compared to when you are using idle, which is the default Python programming environment. Of course, there are other Python programming IDEs that you can actually choose, but for this example, I'll just be using the Visual Studio Code. Now, to begin, first we also have to make sure that we use the nidaqmx function. So let's type in nidaqmx, and once you have the nidaqmx function, you will actually see that there are some constants that actually require in the LabVIEW example code, which is the default, the edge, and all that. So we also need to make sure that we call in the nidaqmx constants, and from the constants we need to import several functions here, which is the one acquisition type. This actually gives us the value for constants and finite. Next is the terminal configuration. This is for us to set whether we want the acquisition to be differential or NRSC. Next is the voltage unit to give us the what kind of measuring units that we want to set, and lastly would be the edge. Lastly would be the edge. Once that is done, we can actually start proceeding to creating a task using the ni task is equals to nidaqmx task. So once we call this will actually initiates or initialize a variable that holds the value task, and in this task we also need to put in the AI channel. And once we have called in the AI channel, we can actually access the what kind of AI channel that you want to use. In this case, I actually want to use the analog input voltage channel. analog input voltage channel. And once we have already called this method, we can start filling in the variables. So in this case, what kind of physical channel am I going to be using? So let's put this as div1 device 1 AI0, which is exactly the same with what we actually set in the LabVIEW example code and also in nidaqmx. Next is we can actually put in what kind of name to assign, but usually I'll just leave this as empty. And the next value would be the terminal configuration. So let's type in terminal configuration and we put in here default, exactly the same like the one in the LabVIEW code. Minimum value, I will actually set it as -5, just the same. Maximum value also 5, right? And then we have the units. So let's put in voltage units, volts. And probably we also have another parameter input here called custom scale, but usually we can just leave this empty. We can actually leave this empty. Depending on how you want to type your Python code, it really depends on how you do it. I just do it this way so that it's easy for me to look into all the parameters at one go. Now that we have already configured the task and the analog input channel, the next is actually we need to configure the timing function. And we need to configure the sample clock. So configure, and we can see there's a sample clock timing here. Once we have called this method, we need to put in what other values. So I'll just put this as 1000. It's the same as in the LabVIEW code. Next is the source. Now the source here, we can actually use this as onboard clock. At least in this example, we'll just use this as onboard clock. Active edge, we put edge, we call the edge constant, and we just put it as rising. Lastly, is there any sample mode? Sample mode would be acquisition type, and we put it as finite because this is a finite acquisition. And lastly, how many samples per channel do you want to acquire? So let's put this as 1000. Once this is done, we have already configured the timing. Then next we can just start the task. So let's start the task. Once you have started the task, I also want to read how much values that is actually being showed, or at least acquired. So we can actually use the task.read method. It will actually return this, but of course I want to display my value here, so let's print this out. Once I have already printed out, it will actually appear here on the terminal and on the right hand side of the terminal. Once I've actually print that out, I can actually just stop the task stop, and task close, which is the equivalent for LabVIEW clear and LabVIEW close. So once we actually have this, let's save this and press run Python file. So we should be getting some values, probably like 1000 values here. But in this case, I'm only getting one value. The reason is because I haven't put in how much number of samples that I actually want to read. So let's put this the 1000 and run it. So I should be getting an array of value here, which is a lot here. And probably this is the values that you can actually see. Probably this is 1000 samples. What if you want to display these 1000 samples? So probably the easiest one is actually to use a Matplotlib. So let's call Matplotlib. Let's say import matplotlib.pyplot as pt or plt. I think plt is better. Yeah, plt is better. So let's call plt. And once you have that, I actually don't want to print my values. Instead, I just want to set the values to my plot. So plt just plot task read 1000 value. Yeah, just put this exactly in, and plt show, and show it. The thing about the code here is that it can actually plot, it will plot and show the value, but the task will not be closed until you close the plot. So let's see this. So the Python file will only stop running when we actually close the Matplotlib, the graph itself. So let's run this. So you can see that it is actually showing here 1000 samples from 0 to 1000 samples here. And once you close the Matplotlib, then the Python file or the Python script stops. So this is an example of using DAQmx, analog input, finite acquisition in Python, and of course a very simple example on displaying the value or using the Matplotlib plot. And probably in the next video I will actually try to do continuous acquisition, and in the continuous acquisition, since it's actually using a while loop, so there are actually two methods to do it, so that I will cover that in the next video. Thank you for watching.